Reviewing the Year 11 end of term 3 test, starting with one structured question with 10 marks. And here we have a graph of atmospheric pressure with altitude, and we're asked to explain why atmospheric pressure decreases with increasing altitude. And there are 3 marks for this, so we need to try to make 3 points. So, first point, the pressure is due to air or gas molecules or particles colliding with the surface, with an area, let's say. Now it's important that when you're talking about collisions, you're not talking about collisions with each other. If you think about it, gas molecule collides with another gas molecule. By Newton's third law, the force of this one on this one is equal and opposite to the force of B on A. So the force of A on B is equal and opposite to the force of B on A by Newton's third law, which means that there is going to be no pressure created on a macroscopic basis, on a large scale basis. It is the collisions with the walls of the container, it is the collisions with surfaces that cause the pressure. So pressure is caused by the air molecules colliding with an area or a surface. You have a lower density of air or fewer molecules, or they are further apart. So fewer collisions, less pressure or lower pressure. So see how the answer is structured. When you have a 3-mark question, you need to look for your 3 independent points to make. What causes the pressure in this case? What's different about the high altitude? And as a consequence of those 2, why the pressure would be less. When flying, the pressure inside the cabin of an aircraft is kept at 70 kilopascals. And the first thing that I would note if I was you is that is kilopascals. So that's 70,000 pascals. And I would just remind myself that is Newton's meter squared. The aircraft window has an area of 810 centimeters squared. And we want a force, which is going to be in newtons. So we're going to have to convert that into meters squared. And there's 100 times 100 centimeters squared in a meter squared. So if we divide by 100 times 100, we'll get 0.0810. So we have the pressure inside the cabin at 70 kilopascals. We're asked to work out the resultant force, the overall effect of all the forces, and that's due to 12 kilometers. So if we look at our graph and we come to 12 kilometers, well, 12, 14, 16, 18, 20, there's 12. So that's the pressure in kilopascals. So we have 20 kilopascals is atmospheric pressure, and we have 70 kilopascals, which is the pressure on the inside. So the net effect of that, the resultant pressure, if you like, is 70 minus 20 equal to 50 kilopascals. Now, there's a mark for reading the 20 kilopascals and the conversion of the area into meters squared. One mark for those two things. So we've got 50 kilopascals. And that 5.0 times 10 to the 4 newtons per meter squared acts on 0.081 meters squared. The force, of course, is the pressure times the area, because pressure is force divided by area. And if we do that, then we get an answer of 4050 newtons. We don't need to worry about the units because they're there, but we should always think about it. But it says give your answer to two significant figures. That's 3. So it's 4100 newtons to two significant figures. So there's a mark for the two sig figs. There's a mark for the calculation. There's a mark for the difference. There's a mark for the conversion and reading off the graph. 5 marks. So half this question is on that calculation. And then finally, explain why the window has been designed to have this shape. Well, you have a larger force inside. Remember, force is pressure times area. So you have a higher pressure, but you also have a higher area. That inside keeping the window in place. I don't feel too bad if you didn't get that answer. I have been marking this question for a number of years now, and most people don't see what the examiner was driving at there. That happens sometimes. It's just unfortunate that 20% of your structured question was on that. However, hopefully now you can see what that was about if you didn't before. Looking at the multiple choice questions then. Question 1. Look at the diagrams of a light ray as it passes from air through a glass block, which diagram shows an incorrect refraction. Well, here we have one that's hitting the boundary at right angles along a normal, so it would pass straight through. Here we have it going from air into glass, and it's striking this boundary at right angles, so it would come straight through. So B is looking wrong. Let's check the others. So it comes in at an angle into the glass, bends towards the normal as we'd expect, bends away from normal as we'd expect. Now you might say that also bends away from normal. It does, but because this is striking the boundary at right angles, it will go straight on. And here, bends towards the normal, bends away from the normal. So B is the wrong answer. That is to say, B is the incorrect diagram and the correct answer. Question 2. White light passing through a prism, spectrum is seen. It ranges from red to violet. Why does the violet light refract more than the red? Violet changes frequency more than the red. Well, we know the frequency does not change during refraction, so that's wrong. Violet has the largest change of speed. Well, that would make sense. The smallest change of speed, well, clearly only one of those is right. And the violet light increases in speed. Well, we know that's not true because light travels at its fastest in air or a vacuum. Anything else it travels more slowly in. So the answer is B again for question 2. The largest refraction and the largest change of speed go together. Very similar question here. Red light refracts when it enters glass from air because its speed changes. If it was blue light, what would happen? Would it refract less than the red because its speed in glass is greater? Refract less than red because its speed is less? More because its speed is greater? Or more because its speed is less? Well, it will refract more, and actually, if you refer back to this question, you can see that. It will refract more. That's because it is slowed down more. So the answer is D. Question 4 then. Those of you using the unlocked version of this were faced with an impossible question because the wavelength bit was missing from that question. Sorry about that. So question 4 then. We have 2 Hertz, 2 meter wavelength, and we want to know how long it takes to travel 12 meters. Well, 2 Hertz, 2 meters, so you've got 2 lots of 2 meters. Every second, 4 meters in 1 second, so it'll take 3 seconds to travel 12 meters. So the answer is C. Question 5. The fluid is compressed by pushing the plunger as far as it will go into the body of a sealed syringe. Which of these statements is true? There is a net force on the plunger. There is no force towards the nozzle. There is a force parallel to all points on the surface of the fluid. There is a force at 90 degrees to all points on the surface of the fluid. Well, this is about fluids being incompressible, or liquids being incompressible, strictly speaking. So, if there was a net force, then the plunger would still be moving. It would be accelerating if there was a net force. So that's not true. Clearly there is a force towards the nozzle because, having pushed the plunger, the force is transmitted through the liquid. So there is a force towards the nozzle. A force parallel to all points on the surface of the liquid, forces left and right and up and down? I don't think so. The forces will all be in this direction at 90 degrees to all points on the surface. So the answer is D. Question 6, which of these has the highest frequency? Well, you just need to know that the answer is gamma. Question 7, a longitudinal wave passes through a slinky. Which pairs of coils are 1 wavelength apart? So we have W and X are both in the rarefaction, low pressure area, so that's no good. Y is the middle of a compression. Z is the middle of the previous compression, perhaps, maybe the next compression, depending on which way the wave's going. So 2 successive compressions, Y and Z. So the answer to 7 is D. Question 8, which of these is not true of all electromagnetic waves? They are all transverse. They do not all have the same wavelength. They can all travel through a vacuum, and they can travel at 300 million meters per second in a vacuum. So the one that is not true is they have the same wavelength. They don't. Which of these travels as a longitudinal wave? Question 9. Light is transverse. Ripples from a stone dropped in water. Water waves are transverse, we call them. Sound is longitudinal. Ultraviolet is transverse. The answer is sound C. Question 10. Which light ray shows the correct reflection from the plane or flat mirror? So we're looking for the angle of incidence and the angle of reflection to be the same, and that has to be B. Remembering that the angles are measured from the ray to the normal. What is the wavelength of this wave? Well, we're looking at 1 complete wave, and reading off the scale, we're looking at 3.5 centimeters. So the answer is A. Question 12, what is the amplitude? Amplitude being the maximum displacement from the rest or equilibrium position. So it's as high as the peak goes or as low as the trough goes. And you've got 2.4 there. So the answer is C, 2.4 centimeters. A green tennis ball is viewed through a blue filter. A green tennis ball appears green because it reflects green light and absorbs all other colors. So if you look at it through a blue filter, which only allows blue light through, then this isn't reflecting any blue light. It absorbs all the blue light that strikes it, and therefore no blue light comes through the filter. So the answer to 13 is black. Convex lens. We would expect this ray to come out through the principal focus. We'd expect this ray to go straight through the optical center. And we'd expect this ray that comes in through the focus to come out parallel to the principal axis. So that's what we're looking for. And that one, A, is the only one that meets the criteria. So this is about knowing your three special rays. Comes in parallel to the principal axis, comes out through the focus, principal focus, for a convex lens. In through the optical center, comes back out undeviated. In through the principal focus, comes out parallel to the principal axis. A. 15. Seismic waves can be categorized into two types, P and S. Which of the following statements about seismic waves is false? Well, P waves are longitudinal. S waves cannot travel through a liquid, they are transverse. S waves travel through solids and liquids at different speeds. All waves would do that. Except S waves don't travel through liquids. So that would be wrong. And P waves would travel through solids and liquids at different speeds. So 15, the answer is C. 16. The average surface area of the human body is 2.7 meters squared. Atmospheric pressure is 1 times 10 to the 5 newtons per meter squared, or pascals. What is the force exerted? Well, pressure is force divided by area, so the force is the pressure times the area, which is 2.7 times 10 to the 5 newtons. You should always think about your units. So that is 270 kilonewtons. Do we have that? We do indeed. The answer then is B.